Hi, everyone. So I'm Nick Turusin, and I'm lead data scientist at Anna Money, or simply Anna. So today I want to share some insights into how we leverage LLMs, and most importantly, the strategies we developed for cost savings. So what is Anna? Anna is a business current account for sole traders, for small businesses, for freelancers and startups in the UK. So as you can see from the interface of our app, it's a chat-based application, which is not a very common thing in our industry. So what sets us apart from our competitors is the integrated AI accountant that can file corporation tax, VAT, and self-assessment for you. So let's have a look at our main LM applications that we have. Firstly, this is our Anna chatbot. Customers can interact with it to perform some core features like creating payments, issue invoicing, or for example, running a payroll if they have employees. Say they can also request a new card or account statement in the chat. Ask some other questions. So currently, the AI automates about approximately 80% of requests that customers have. So second and the main focus for today is AI accountant, particularly transaction categorization, but it also involves processing financial documents and assisting customers in the chat with their tax and accounting questions. It can be or a phone call. Lastly, we have LLMs that generate account summaries to speed up the review for fin crime prevention purposes. So this is the distribution of our costs roughly 4 or 5 months ago. As you can see, the majority is taken by the AI accountant, almost 2/3. And obviously, the cost optimization is a crucial area for us, and we wanted to explore. So let's understand why transaction categorization. So why spend money on LLM for transaction categorization? And for most transactions that our customers have, we don't do this. So we have traditional machine learning models like XGBoost or rule-based system that can pretty accurately categorize customer transactions. But let me give you an example. So we have imagine we have two customers. One is a builder, and the second one is a IT freelancer. So they bought something from the same store. Shall all the transactions categorized be categorized in the same way? The answer is no, because if a builder say buying something from B&Q, it is their direct cost, so something that they need to operate. And if a IT freelancer buys something from B&Q, say they want to upgrade they bought a wooden shelf or something like that. So this is a home office expense, which will have different tax implications for both customers. So, and customers do businesses in hundreds of different industries, and each industry have its own rules. So obviously, to build on traditional ML and rule-based system for that purpose would be very hard and very difficult. And we want to use LLM, and we started to use LLMs. So LLMs are good at understanding complex context and nuances of our customer businesses and their transactions. They also can understand our internal accounting rules. Many accountants do their work differently. There are many reasons for that, but this is so our accountants have their internal how they have their own rules. So thirdly, is this ability to explain decisions clearly to customers. Say, I want to explain the same thing that they bought something which is home office expense to a customer. We want LLM to be able to do this. We know that LLMs are multimodal, and it comes in handy with documents. So when you categorize a transaction, you can have a document attached. So you can use the information from the document to make the categorization more correct. So, and lastly, understanding of real world context. We want the system inherently know that B&Q is a store that sells building materials. And we don't want to create a rule-based system for each merchant. So let me show you just one more example how the input and output would look like for this task. So in this case, we have a transaction and a context. Context is attributed to our customer. So our customer is company Fire Safety Limited, which is a consultant operating primarily offering fire safety assessments. And they received some payment for £200 from unknown company Next Global Limited. So at first glance, that can be very generic payment. Can be anything. Maybe they transferred money, or it was a loan, or maybe it was an income. But if we look closer, we have a document attached to this transaction, and the invoice actually tells us that that was fire risk assessment, a core service that provided by our customer, and actually this aligns with the nature of business. So in this case, the model predicts taxable income, which is correct. And we also ask it to produce some other fields or attributes of the output that we need. One of these is explanation or reasoning, so that we understand why the model categorizes something as, for example, as taxable income. There is a citation. We want the model to be able to refer to our category rulebook written by our accountants. And we need to be able to show customer-friendly explanation. So in this case, the explanation is this payment is for fire risk assessment you provided to Next Global Limited, which is part of your main business activities. It is categorized as income, and this sophisticated process will translate into category suggestions that will be shown to customer. App will flag some transactions that require attention, and in this case, it suggests to categorize something as wages and explains the decision. So how do we manage this at scale? So company transaction initially categorized by simpler model like XGBoost. In this case, we have like 3 companies. They enter the pipeline after the financial year ends. So this is a not real-time categorization, which is very important to the stock. I will describe it later. So we take these transactions, we filter out all the transactions with higher confidence, and we do not need LLM categorization for that. And they now being processed, and we produce some corrections for the customer. Usually, in the case of corporation tax, they have 9 months to review them. So under the hood, it looks like this. So you have a free requests for your clients, for free clients. Each request contains a system prompt, which is a categories rulebook in our case, company context about this client. So it's a list of directors, list of employees, the data we parse from company's house and some other public resources, the description of the nature of business taken from KYB, and yeah, and the transaction batch. So And this forms the input. We have 3 requests. The system prompt in our case is approximately like 50,000 tokens. And company context on average is like 500 tokens, and transactions also around 500 tokens. So after we receive predictions, we can use them and create suggestions. So when we started, we chose like mid 2024. We chose Anthropic Claude's 3.5 model provided by Vertex AI. So why we did it? Because we evaluated on a different test sets that we have. It seemed like to be the best model at the time. And one other feature is that when we looked at customer-friendly explanation and compared it to other models like GPT, OpenAI models, much more transparent to customer. So Anthropic usually have models with a large, relatively big context. So every day a new model, and like Olama now has 10 millions. Okay, but 200K is also quite big context, and you can use this window for input. You can use up to 200K for input, but your output is limited by 8,000. What is important is that output token is exactly 5 times more expensive. You need to consider this when you try to optimize your costs. And yeah, if you look at other models, you will see that usually the output is like from 3 to 5 times more expensive than input. Simply put, the reason is processing input tokens is more efficient. This can be done in parallel. Output tokens are generated sequentially. So some of the, like, we obviously understand that modern LLMs have their flows, bottlenecks. Mariam already mentioned KV cache several times. And during this conversation, I will touch on some techniques like prompt caching and offline predictions that are actually some kind of a workarounds because of this problem. So some of these techniques actually save a lot of money, but will they be relevant tomorrow? We don't know. But today they're relevant. So system prompt. I just attached the table of contexts of this document that our accountant wrote. And as you can see, it has more than 100 pages, and the length is about 50,000 tokens, which is a huge document, and it describes how the system should behave and categorize different transactions. So let's try to fit our data in the context available. So then we have our first component is system prompt, which length is 50K. Then we add a profile of the company, usually from like 500 tokens to 1,000 tokens. And then there is a transaction batch, which is roughly 8K, and expressed in number of transactions, it's up to 15 transactions. Why is it so small? Because we can only fit 15, up to 15, because our predictions, we have just 8K of output to predict categories. So this brings us to cost optimization. So say we have a client, they have 45 transactions, and we split them into 3 requests. We see that to get 45 predictions, we consumed about 180K of input, and to get just 45 predictions, which is not efficient at all. And February this year, Anthropic released a new model called Claude 3.7, which has the same context, 200,000, the same price, absolutely the same price. And what's the difference? The difference is that they now allow us to use 16 times more output than it was before. So it seems like the bottleneck is now disappeared, and we can fit more transactions into the into a single request and receive like up to 145 predictions just in a single request. So that would dramatically decrease the number of calls we do, LLM requests, and will save money. So let's formalize some strategies we have so far. So please do not over rely on expensive tools without a real need. So there are classical machine learning models, smaller models, smaller language LLMs models for simple tasks. And yeah. So secondly, like upgrading models is a like cost optimization strategy in itself. So they can be more cost effective, but even in our case, where the price was exactly the same, we utilized the context better and we could save money. I will share the results at the end of the presentation. And yes, just to probably many of you seen this chart. It shows LM meeting a certain benchmark and the cost per million tokens. So it has been dramatically decreasing in around like 10 times a year. So though it seems like a strategy, cost optimization strategy in itself, on the other hand, models become more intelligent, more business opportunities are being unlocked. Like several years ago, like many of us did not spend anything on LLMs, but now we spend, and more business opportunities are being unlocked. May result in higher spendings in absolute numbers. So now we'll talk about enabling offline predictions. So offline predictions is basically an agreement between you and LM provider so that you agree to wait up to 24 hours to get your predictions, and for that you will get a discount. So discount for top 3 providers is the same. It's 50%, and then you will have predictions, time to TTL, time to live, which is also need to be considered. So make sure you fetched your predictions within the TTL. So in Anthropic's case, it's 29 days, and unless otherwise you will lose your predictions. So additional benefits. While I was reading Gemini documentation, I noticed this chapter. So what Gemini or Google claim that offline predictions improve prediction consistency, which is a bit unexpected. So consider an online bookstore with thousands of books in its database. Instead of generating descriptions individually for each book, batch prediction can also improve consistency with automation. By processing all descriptions simultaneously, the model maintains a uniform tone, a style across book descriptions, and reinforcing brand identity. So though they do not say it, I think they said it, that batch predictions affect quality. And this is something that you need to be aware. And how to use batch predictions is relatively straightforward. You just need to create a JSON file with your requests, put it somewhere in case of Vertex AI, it's Google Storage. Then you create a request to Vertex AI pointing to your file, and you receive a job ID in return. Then you just regularly check your job ID to fetch your predictions. It can, like, you can wait up to 24 hours. Another helpful technique is prompt caching. So the same way as offline predictions, prompt caching is beneficial both for both LLM providers and customers. So, and the reason is that they don't need to recompute the key value cache again. Customers just tell them what part of their prompt are static. And for these static parts, they save cache once and then reuse it later. So let's have a look at our request. So we know that the static part is system prompt, other parts are dynamic. So basically we can apply the prompt caching to category rulebook, which is long, 50,000 tokens. And yeah, let's have a look how different providers implement this. So the price is now a bit more complicated. So first of all, you need to write the cache. OpenAI and Gemini will do it for free. Anthropic will charge you 25% extra for each input token. Then once the cache is stored, you will be sending new requests. And for these new requests, for the cached part of the request, you get these savings. So there are some other things to consider, like there is a storage cost. In case of Gemini, it's not zero. And there is a TTL. It will affect how you actually implement this. And yeah, one interesting thing is that OpenAI decided to choose a different approach. So basically, Anthropic and Gemini, in order to enable it, Anthropic and Gemini will expect from you either parameter, either additional API request, so that they know what you want to cache. But in October last year, OpenAI decided to enable prompt caching for every request that is longer than, as I remember, 1,000 tokens. So basically, it enables for everything. So additional benefits. Prompt caching can reduce latency by up to 80%, which is significant, I would say, because something that was initially created to reduce costs may have absolutely different application. So now we work on adding LLM task consultations via phone call. And on a phone call, the latency is crucial. Like you don't allow yourself to create some pauses or awkward situations. The conversation should be consistent and the latency should be relatively low. So in order to answer like tax or accounting related questions via phone call, you obviously need to use powerful models. And secondly, you will need to use internal knowledge, which in the case of categorization is kind of big. So, and for that use case, you can enable prompt caching for a different purpose. So for now, I will also recommend you enable application level caching if possible. So in our case, we can reuse predictions, for example, by categorizing unique merchants per client once and storing results for future use. And sometimes use self-hosted LLM solutions. That can be a game changer when there is a high load and there is suitable open source model that you can use, that you want to use, and enough expertise in the team, because it's it's not an easy thing to do. And obviously, yeah, you need to be sure that you want to use this model for next several months. Otherwise, you need to implement it from scratch. So results in conclusions. So we applied these some of these strategies to AI categorization use case and review the results. So 3.7 now. First version is version without optimization, and monthly costs by applying offline predictions, monthly costs expectedly decreased by 50%, which is fixed, and we understand that this is very straightforward. And then we added better context utilization. So in this case, we reduced the number of calls and utilized the context better. So that gave us additional 22 percentage points, and the total saving is now 72%. And prompt caching, 75% in total. So please be aware that the combinations could be different. So in our case, we first added offline predictions, then improved context utilization, then added prompt caching. It depends on your use case. Please try to understand what will work best for you. And lessons learned during this journey. So when we enabled longer predictions for more than 100 transactions, we noticed that it increased the share of damage to irrelevant predictions. So each output should contain a transaction ID. Sometimes we could see that the ID is either made up or there is a mistake in the ID, so we cannot attribute the prediction to any of our transactions. And there can be some irrelevant predictions. So though the share of them, like about 2-3%, before we used such a long output sequence, it was 0. So this was not expected. We can live with that, but this is, an important point here. Savings from Anthropic's prompt caching combined with offline predictions are actually difficult to predict. Even in their documentation, they say prompt caching works on a best effort basis and efficient usage is not guaranteed. In our case, we see that it gave us additional 3 points. And always manually inspect your input after making changes to check what can be improved. We had a very simple error in our input preparation script that unintentionally did double serialization of JSON that produces some extra chars that you actually don't need, and which increased consumption, and that could have been avoided. So we noticed whatever you do, there is a chance, whatever strategy you use, there is a chance that that may impact your quality, quality of your solution. So we remember this Gemini's comment on more consistent, whatever that means, predictions. We saw that we got more hallucinations with a longer context. So this brings a lot of money or saves a lot of money, but of your solutions. This is full list of the strategies. And thank you. Just in case if anyone has questions. So when we started, we wanted to move fast and we considered adding a rack, obviously, but we also had a some other experience of using a rack for other applications. So Anna also published public chatbot, tax chatbot called Tax Therapy. So we use RAG in this application. It is RAG over GovUK knowledge base. And then you obviously see some flaws in this approach. So for example, customer asks about something, what's the best way to split salary and dividends? Most efficient way. And the way RAG works, the LLM will ask some search query, and then the RAG will perform the search. But this part where the LLM comes up with a relevant query works very badly sometimes. So, for example, for that case, salary dividends, it may you need many information to actually to do a correct calculation. You need actual tax rate, you need dividends allowances, and some other things. So you need to do multiple queries, and that introduces a completely different part of the pipeline. So this part of the pipeline should be evaluated separately. It is obviously time consuming. At the time, we decided that we will use the entire prompt, entire accounting rulebook, because this way we save time. We acknowledge our current consumption, and we understand that there are some other ways to decrease the consumption, but we want to be sure that the quality is the highest as possible, because there is an assumption that if you leave the whole category rulebook in the content in request, it will produce the better predictions. For now, it's just retry. Go and no. I mean, take the failed predictions and just run another query, another request, and that is not a super elegant solution, but it works. And we also decreased. So I showed that theoretically we can use up to 145 transactions per request. So we just decided, okay, we won't use the maximum allowed value. We will like use like 120, so that we like found the trade-off between hallucination share and the number of transactions we categorize in one go. Prompt caching and yes, so all top 3 providers, OpenAI, Anthropic, Gemini, claim that they can be combined. Though, as I mentioned on this slide, Anthropic clearly mentioned that we will try our best to make use of your prompt caching, but nothing is guaranteed, because this request now will be launched, scheduled in a less predicted fashion. And if it works, okay, we will save you some money. Otherwise, yeah. But OpenAI, yes, OpenAI, it seems like they have a better approach, and they try to cache all the time without your even without your explicit request. You were first.
Have you tried fine-tuning models? Oh, yeah.
Yeah, I have the question. Yes, I described that there is some process aspect of how we make decisions, what model we want to use, what technical solution we want to use. With fine tuning, we never found a suitable application to actually use it. Maybe you have a different experience, but we just could not justify the time. And again, you always remember that you just wait a month, you get a significantly better model, and you need to refine tune it again. So maybe if you do this just for the sake of cost saving, that might be inefficient. So Anthropic is quite good in this regard, but again, to this point of longer context, that was exact the problem. So we, I think JSON was synthetically correct, but the content of the JSON wasn't. So you expect to receive at least a transaction ID that you want to link the prediction by using this ID. But sometimes there are IDs that never exist. Like you send some transactions and you get some transaction in return, but the transaction IDs are made up. That's kind of. Yes, just as I answered, yes, we'll just retry again, and that's it. I saw some question there. Yeah.
You mentioned while tried a few different forward. Did you have an objective to make that decision?
Yeah, so we had ML models before LM appeared. And obviously, we needed a way to evaluate quality of XGBoost, let's say. And since then, we have test sets, and you always need a test set. It doesn't depend whether you use LLM or traditional machine learning model. But yes, we used some of our test set annotated by accountant. So we compared GPT-4 or Claude, maybe something else. I don't remember exactly. And I think the metrics-wise results were similar, but when our team looked at the friendly explanations that will be shown to customers, we did not have any discussion. We knew that we want to use Claude. Any other questions? Yeah. Point 4, always revalidate the metrics of your solution, even if you don't expect changes due to optimization. So as I mentioned, this Gemini excerpt from the documentation, they tell us that through offline predictions, you're getting more consistent predictions. This is unexpected thing to read on Google's documentation. But yeah, you need to evaluate model all the time. So for the things we implemented, obviously the answer will be yes, since like we decided to go with them. But if we go into and check the whole list, for example, self-hosted LLMs, we just not big enough to justify the potential savings. Once we have more clients, once we have more transactions that we need to categorize, or we enable another LM application, and we see that that option becomes more relevant, that something that we would consider. For example, we have been considering it for real-time categorization. So what I described today is all about like use cases when there is a long timeline when where your client is preparing for tax return, and you always can delay this the type of predictions because you have many months to actually generate those category suggestions. And for real-time prediction, if we say launching a new product, we launched last year, we launched in Australia, we don't want to we consider retraining XGBoost again for Australian data, but now it's to just use LLMs. And for real-time categorization, there will be latency and some other constraints. But I also mentioned that you probably need a really high expertise in the team to be able to manage this. And yeah, maybe sometime we will use self-hosted LLM, but this time we decided not to go with it. So I wish you everyone good savings on your journeys. Thank you.